All right, so last time we were talking about partial fractions, and let's just do a real quick briefing again over how partial fractions work. I'll go back a few slides and talk a little. The idea of doing partial fractions is, first of all, you do long division if the numerator is bigger than the denominator. Then the issue with the partial fractions is that we factor the denominator, and then we let sort of dummy variables of A, B, C, those kinds of things be the coefficients of separate fractions with my new factored pieces of my denominator. And then I combine my fraction all back in together, so I get a new numerator that's got lots of variables in it. And I can compare that new numerator with the A's and the B's and the C's and the D's and whatever to the original numerator I had. I can pick out the pieces that were coefficients, the coefficients of the pieces that match. So if they all have x squared, they all have to add up to the x squared value in the original problem. If they're all x's, they have to add up to the x value in the original problem, and so forth. And then, once I'm able to separate them, I'm able to do the integration for them. Does everybody remember that process as I described? Okay. We'll assume. And the one we're going to look at this time has a x squared minus x plus 9 in the numerator, and then an x squared plus 9 squared in the denominator. Now, I bring this one to your attention not because of the difficulty of factoring the denominator, because it's actually already factored for you. It has itself squared, and I can't factor the x squared plus 9 any further in the real numbers. So there isn't any unfactored portion of this denominator as it is. So you might be saying, okay, well then what do we do? Well, if you remember from last time, in fact, I'll flip back to this slide. Do you remember this one right here where it had an x squared when I factored that denominator? And then I let one of the denominators be x and the other denominator be x squared? I'm going to do that for this particular problem as well. So I'm going to be able to take this denominator, and I'm going to write one of my denominators as x squared plus 9, and that is all by itself. And then the other denominator is x squared plus 9 quantity squared. So far, so good? We did that last time. Now, here's what we didn't do last time. Last time, every time we did a numerator, it was always over something linear, with one exception, and that exception was right here where I had b over x squared. But I was like telling you that this is sort of different because it's a duplicated factor. X was already there, so the x squared I don't have to worry about it, and we treat it much like it was linear. Well, on this particular problem, the first denominator isn't linear. It's quadratic. It's x squared plus 9, which means I need a degree 1 less on the top. So I don't want a constant on top. I need a linear term on top. Okay, it means I need an x in there. And I also need at least the possibility that there's a constant as well. Okay, I need a darker color a sec. So this numerator is actually going to be ax plus b. It's like writing mx plus b, right? Linear equation, y equals mx plus b. Well, I'm going to use the a just for consistency's sake. I've got ax plus b. Now, the second one also needs to have that same feature, okay? The factored form of it is also quadratic, so I don't have to do this as though it was a power of 4, though it is a power of 4. We recognize that, right? But I can still deal with it as though it's linear on top because the factored portion is linear. So this is cx plus d. So far, so good? Yeah. I think that's my phone. Alrighty. Okay, so what we did last time then is our goal is to combine these fractions back together, right? And the way that we combine them back together, again, I'll do my algebra over here on the left, is that I actually need to get a common denominator. Now, the common denominator is the denominator I started with. It always is. I mean, that's kind of the whole point, is that I need to get the denominator I started with to be able to do a comparison. So the first fraction actually has ax plus b. And what would I have to multiply it by for the x squared plus 9 in the denominator to have a common denominator it started with?
X squared plus 9.
Right. I'd need it to be multiplied by x squared plus 9. But the second denominator denominator pair, right, that second fraction, that denominator already is the denominator that I want, right? So I don't have to do anything to it. It is going to stay exactly the same. Okay, everybody with me good? All right, so far? All right, I need to simplify the left-hand side. That is, I need to FOIL and distribute everything out. So ax times x squared is, thank you, ax cubed. And then I have ax, outside terms, ax times 9. 9ax, thank you, Dylan. I have my inside terms, b times x squared. bx squared. And then my last term is b times 9, 9b, right? Again, plus cx plus d. And what I need is for that to equal x squared minus x plus 9, because that's my original numerator. Okay, so what do? Well, I need to identify what the pieces are that I have. So I usually start, and I did this last time too, at the highest exponent. I've got an ax cubed. How many x cubes are in my numerator? None, i.e. 0, right? So I have, in essence, 0x cubed that I'm supposed to be getting that ax cubed to equal. What's a? It has to be 0. I shouldn't have any x cubes because my original numerator had no x cubes. So if I'm looking at the x cubes, I need to know that a equals 0 because it's a in the left-hand side, and in the simplified one that I'm trying to get it to equal, there are 0 x cubes. All right, so let's do the next one. Let's do x squared. So here's an x squared. That's my only one, isn't it? All right, so x squared. So I have b of those. And how many of them do I have in my original equation? 1. So this is great. I know that b is 1. No question, right? This is probably the best linear system that I've ever solved. It's the easiest so far anyway, right? I haven't had to do much deciding or much algebra or anything. All right, my next issue then is to deal with the x's. So I've got 9ax and I've got cx. And so this is my x terms. So I've got 9a plus c. And what does it have to equal? -1, right? It's the coefficient on x that it has to equal. But a is 0. So what's c? C is -1. So a is 0. So c is -1.
Where did the -1 come from?
Do you mean this -1 right here, Emily?
Yeah.
It came from the coefficient on x. Yeah. Okay, I need a little bit more space, so I'm going to creep in on the bottom on this side over here. I need my constant term. All right, so I have 2 constant terms in the expansion on the left. I've got a 9b, and I've got a d. And this has to equal what? In the original equation. I should move a little bit for you guys.
9.
It has to equal 9. There's a 9 in my original equation there on the right-hand side. So d is 0 because b is 1, right? I already found b is 1, so this is 9 times 1 plus d is equal to 9, so d must be 0. So this is actually really friendly because I actually ended up getting a couple of things to be 0, and that doesn't always happen. So this is pretty nice. That blue is really hard to see, actually, isn't it? Let's just change to green. We'll see about that. So right now my equation, that's pretty good, looks like ax, but that's 0, plus b, and b is 1. So this is 1 over x squared plus 9, plus, and I'm supposed to have cx, but c is, oops, it's -1. I think I left a negative out. C is -1. Sorry, -1x, because c is times x. So -x. Plus d is 0, so there's nothing else there. Over x squared plus 9 quantity squared dx. is everybody okay with that? All right. Now, there's two pieces of this, and one piece I can actually find the antiderivative for right away. The other one's going to require a bit more work. Which one can I find the antiderivative for right away? Nope. First, I can. It requires that you remember some formulas that we've dealt with. Not natural log. Some arc something. Do you remember those arcs? They also had that feeling of something in the denominator going on like the natural log did. So remember that natural log only comes about when we actually have a linear power of x in the denominator, and this one's quadratic. So this is an arctangent issue. Okay, so let me move on the next screen. Okay. Alrighty, so the first one is arctangent. Well, at least that's part of it. So somebody flip over in your book, since we're having difficulty remembering how the arctangent one works. What's the antiderivative of 1 over x squared plus 9? Okay, so do you know what a is in our problem? 3. It is 3. A is the constant part that's squared, and that's 3 in this problem. So it's this 1 over a, or 1/3, arctangent of what was next, Cameron?
X over 3.
Yeah, so the variable, the part the variable is that's squared, and then divided by the constant squared again. So that's the first part. The second part, let me rewrite. I pulled the negative out, notice. How am I going to deal with this piece? Yeah, how do you know it's going to be U substitution, or how would you know that would work?
The power on the inside is 1 more than the top.
Right. The power on the inside of that parentheses is exactly 1 more than the power on top. So U substitution, with power rule, it decreases powers. So that's very friendly. So if I let U equal what's on the inside, as Cameron said, which would be the x squared plus 9, then what is du? Close. 2x dx. And of course I don't have a 2, which is what Dylan was kind of noticing there, right? So I need the 2 to come on the left. So I have this rewritten 1/3 arctangent of x over 3 minus 1/2 the integral of 1 over u squared du. Of course, I don't really like writing this as 1 over u squared. It's more helpful to write it how? U to the negative 2. Okay, is everybody with me so far? I need antiderivative then of that piece. What's the antiderivative of u to the negative 2? Yes, so it would be u to the negative 1 divided by negative 1. I'm going to write it that way first, but you're exactly right, Dylan. Like this. And then I need 1/3 arctangent of x thirds. That doesn't look very good, but it's a 3 still. And then this would be a negative, with a negative inside would make it positive. And then it'd be 1 over 2u plus c. Am I done? What's missing, Kendra? Yeah, I need to do something about that u, because I've got 2 variables in this problem, and I didn't have a u in the problem to start with. So I have 1 over 2, and then I know what u is. It's x squared plus 9. What's that? I don't know. I'll check. Okay. Any questions on that?